Good afternoon and thank you for coming. Welcome to FESPA. It's a spectacular event. My name is Mike Plier from EFI. I am the Business Development Manager, Director for the vacuum forming and as it relates to inks. We're going to cover a lot of material here today. And how many of you here actually vacuum form? No one? All right, well, let's get started. We're going to cover a lot of material. We're going to go from the basics to the more advanced applications. A little history lesson of how we got to where we are here today is in October of 2014, EFI builds on an existing relationship or partnership with a company called Polymeric Imaging, my former employer. At that time, EFI acquisitioned all the patent IP formulations and anything to do with inkjet thermoforming and related technology. Thermoforming dovetails into a worldwide application, coast to coast globally, and it offers 3D applications that offer spectacular color strengths and unlimited design applications. It also adds new expanded opportunities for printers who normally aren't into that particular market. It allows you to venture into the three-dimensional graphic applications from industrial to commercial to POP to advertising in the works. What if you could digitally print these signs now? These are the super format signs you often see here in town, and just go for a walk, you see them all around you. These signs are typically done with methods used since the 40s. Some of these signs are 1 meter by 5 meter, sometimes exceeding 250 pounds. Typically these are spray, mask, dry, peel, cut, spray, mask methods. Very time consuming, very labor intense. These are some more brands that would very likely be candidates to be introduced to the thermoforming market or existing thermoforming applications. Okay, let's get started, and I'll go through a little bit of vacuum forming 101, okay? Asked earlier, not many of you here, it looks like are in vacuum forming. During the heating cycle, both the inks and the plastic become malleable. There's a number of buzzwords used in the market. They'll start out with thermosag, that's where the plastic becomes malleable, goes into a glass transition phase. At that point, it's ready to be formed and elongated. These pigments used in these systems are extremely high temperature resistant. They also do not have a tendency or will not change during the heating cycle, which is a thermochromatic feature which these inks do not have. Okay. Elongation on these systems, I was often asked, Mike, what's the elongation characteristics of these systems? I gave up trying to quantify percentages. I can clearly tell you that these ink systems are designed to meet or exceed any plastic it is printed on. The deepest draw I have seen to date was 28 inches, over 2 feet, on a ATV mossy oak camouflage fender pattern or a golf cart application. These systems also have a very broad range of adhesion on a variety of plastics, all related to the thermoforming market. Here's a little animation of the thermoforming process. This sheet would be printed, heated, malleable, goes into the bubble, it's draped over the tool, vacuum turns on, coolant goes through the tool, fans turn on, the plastics cool, a blowback allows the material to come off the film. Next part. Here's a variety of vacuum forming tools used. You may hear the term female tool, May tool, drape forming, pressure forming. At the end of the day, all of these processes are done using heat, causing the materials to be very flexible. And at that particular instance, there's a variety of different types of tools used for different types of applications, whether it's tub and shower inserts from point of display, automotive aftermarket parts, point of display. Each of these vacuum forming tools offer particular processing advantages that are specific to a market or the plastic they use. Typical heat ranges, like on a styrene would be 280 degrees, and a polycarbonate typically is in the range of 460 degrees F. The first decoration used in vacuum forming dates all the way back to the late 1940s. The first historical data of the vacuum forming was used for tactical maps during the war. The decorating vacuum process is done the same way as it was done in the 40s. I assure you, I visited customers who have equipment that was first built in the 40s. That was the vacuum forming equipment, okay? What's so special about these inks? As you can see here, these are typical ink sets that you see here on the floor this week. That when formed, or even before they see the heat, they fracture. On the right-hand side is a non-forming ink, and on the left-hand side is the high elongation ink that EFI now manufactures and sells. Just a very short comment about the ink systems themselves. Monofunctional inks are typically the ink systems that are used to create deep draw, high elongation chemistry that doesn't create cracking or mosaic fractures. The original formulas of which I was involved in work fantastic in laboratory environments. However, in the production field, it took a little bit of dialing and several years to perfect this chemistry. As you can see by the short chain links of the chemistry, it allows it to have high flexibility, and great, fantastic adhesion range. On the other hand, here are the inks that you see on the floor here today. Some of the pros are very, very fast cure speeds, high gloss, excellent chemical resistance and scuff and hardness. Limitations are typically processing. You've seen it on the floor, and I know some of you encounter it every day in your shops. Cracking during die cutting, fracturing during bending, folding, embrittlement. Here's just another example to re-establish that this is where we are. Okay, the journey into high elongation vacuum forming, imaging of things, the future of print. What you're not seeing, if you observe on the floor, restaurant chains, convenience stores, retail, we're surrounded by these applications. Most of us walk right by them. I certainly don't. These inks now have a high level of efficiencies, which we're going to go on the next slide about what these products can actually do for you and how they can streamline processing. The big deal is cost savings, up to 95, 93% efficiency on throughput, labor, and here's what we need to do next. Kind of a recap about the previous slide. Vacuum forming surrounds us. These are some prime examples of point of display. The gaming industry was a huge market. Industrial and commercial applications for automotive, sports and outdoor graphics. Of course, accessories for all-terrain vehicle, motorcycles, point of display. Okay, every single one of us in this building and at this show comes in contact with vacuum formed three-dimensional graphics every day, all day of our lives. Every automobile has vacuum formed products in it. Here are some of the markets that are available to us and participating in is aeronautics, the interior trim, the covers, the cowlings, military shielding, weaponry, armor, helmets, agricultural trays, tubs, lawnmower enclosures, gigantic market being the automotive aftermarket, dashboards, wind deflectors, interior door assemblies, marine, canoes, kayaks, hatches, dashboards, electronics, etc. Gaming is a spectacular market. Backdrops, animation. The list, as you can see, is quite large. One of my favorite and one of the easiest to access is the brand signs. I call it the super format market. Next few slides, I'm going to kind of capitalize on that because this digital application has a tremendous impact on this market. A couple things we need to know before we go into that is the ink is only as good as the plastic you're printing on. We have to select the correct plastic for its application. There are two families of plastics. One's a thermoset crystalline, the other's thermoplastic is amorphous or pliable. An example of this would be your handles on a pot and pan, fishing reel handles, tool handles that are typically molten, put into a tool, they cross-link under heat, and they will no longer become thermoformable. They are permanently crystalline, okay? Some plastics have hygroscopic tendencies. If you don't know what that means, polycarbonate, for example, has a tendency to pull water in from the atmosphere just like a sponge. Special processing has to be done with thermoforming of polycarbonates to get the water out of it, because if you don't get the water out of it during thermoforming process, it causes an effect that's called starlighting, which allows light to penetrate because the water has to go somewhere. So they bake this product. Forming temperatures from plastic to plastic varies. High 200s for styrene, high 400s for polycarbonate, and everything else in between. Okay? They select these plastics for a variety of reasons: impact resistance, weathering, dimensional stability, exterior, outdoor applications, etc. With that being said, there also is a huge difference of price from the point of display to the industrial market for these plastics. Here's a good example of the super format signs. I have some examples with me. This particular sign right here is a cutoff of this sign right here. This is a 1 meter by 5 meter sign. Okay? I'm going to give you some examples of real-time savings, okay? This market right here, because of the throughput, the screen printers, even to produce a small sign that's 3 feet by 4 foot, printed on styrene, fairly simple job, with no white, takes them about 6 to 8 hours to make the frames and the screens alone. We haven't printed a single sheet yet, okay? Then another 4 hours to set the print up typically, and another hour and a half to dial in the registration and to hit color. And during this time, they'll go through at least 16 to 20 sheets of registration, dialing in color, and that's if you have a good pressman. And at the end of the day, you still not might hit color, and it may not fit the mold. Then they do it all over again. That costs a minimum of $4,000, and we don't have a good sheet printed yet. Digitally would allow us to print this probably in 1 hour and be able to change graphics 4 different times within the same hour consecutively. That's disruptive if I've ever seen, okay? Tail of the tape. This next is a fantastic example of what this technology will do to the market. It's already having an effect on it as we speak. This sign specifically we'll talk about. This is a real life story at a customer in the United States. It takes this company 7.5 hours to print a front and a back of this sign. That's what the current methods, the spray, the cutting, the mask, more spray, most of the time they're drying. Using the digitally printing formulations and technology, we are able to print 34 signs, these same signs, in 7.5 hours. Okay, again, 7.5 hours to do a front and the back, the old technology. 7.5 hours to do 34. We just put an addition on their building without laying one brick. The amount of capacity that they increased by putting a device on their floor had an immediate impact. Okay, put another way, what would take them 3.5 weeks to produce 34 signs with this technology they currently have, they can do in 1 day. Unlimited applications. You can print it, we can form it. If you can think it, we can form it. Vending, gaming, point to display. Industrial and commercial. automotive fender flares, hunting, outdoor sports and graphics. Does anyone have any questions to date? If you don't have any questions, you don't understand, I don't think. The impact of what this technology is capable of doing will change the three-dimensional vacuum forming and signage market. There is no other way to go. That is truly an unfair advantage.